x equal to new integer 5. Okay, then when this statement will be executed by your JVM will create or allocate memory for your array because of this statement. Okay, and your JVM will create or it will create actually an object, and the size of that object will be uh, 5 multiplied by 4, so 20 bytes. Okay, so it will allocate 20 bytes. Okay, because in Java integer is of 4 bytes, so okay, so and this object will have capability to hold 5 integer elements. Okay, and each element will be identified by index number. Okay, so now say suppose this is 1 2 3 1 2 3 4 5, right? And each element, each box here that you see here is of type integer, and it is of 4 bytes. Okay, and in Java these elements are identified by a uh, index number, and that index number start with 0 0 1 2 3 4. Okay, now say suppose in the next statement you write something like this: x 2 equal to 5. It means you are asking your JVM to store 5, and where you want to store 5? On the element position number 2, right? So 0 1 2. So when this statement will be executed, your JVM will store 5 on this position, right? Similarly, if you say x 4 equal to 10 50, then your JVM will go to object that is pointed by this x element, which is x variable, array variable, which is this memory location, and then it will go to the fourth position. So fourth position is this one, and it will store 50, right? So this is how your arrays work, okay, in any programming language. And each element in the object, in the array object, is of is of particular type, and each element can be accessed through an index, right? Index start with the 0, at least in the Java or any other programming language. But in the map editor I will explain you how we deal with this indexing, because in the map editor your index start with 1. But forget about that for now. So this is the concept of arrays. Okay, collection of similar data type, where we create multiple elements of same type, and after creating them we access each and every element through a index number, like you can see here. Okay, so again, if you want to store if you execute this statement, right, it means you are asking go to the memory location which is pointed by x variable, and then go to the element number 0, and then store 10. So this is the memory location that is pointed by x. Okay, and this guy, you want to access or you want to store something on the element which is on the index number 0. So your index element which is on the index number 0 is this one. So when this statement will be executed, it will have 10. Okay, so this is how one dimensional arrays work, right? How this is how your one dimensional arrays will be created in the memory, right? Similarly, we also have two-dimensional arrays. Okay, we also have two-dimensional arrays. Now, how we create two-dimensional arrays? Say suppose this. Okay, so when JVM will execute this, then you will have a variable called the x. It will point to a memory location in your RAM, in the heap in the JVM, and it will point to an array, right? Now, as you can see here, this time I have two-dimensional array. I have two-dimensional array, right? As you can see here, because I have two dimensions specified while creating the object. Okay, first dimension. Okay, first dimension will have three elements, right? And as I explained you, as I told you, in Java we have concept of array of array. It does not directly support multi-dimensional arrays like your C or C++. In Java, we have arrays of arrays. Now, what does it mean? Now, why I'm explaining you, because this memory structure or memory creation is very similar to what you get in your map editor, right? So in this case, what will happen? Your JVM first create a array object that will have that will have three elements: 0, 1, 2. Why 3? Because of this. Okay. Then each of these elements, each of these fields will point to will point to another array object. Okay, these elements, these fields will point to another array objects, right? That is why we call arrays of array or objects of object. Okay, so you will have another array object created, and it will have five elements. 1, 2, 3, 4, 5. Okay, this will point to this array object. This field will also point to another array object. Okay, and 1, 2, 3, 4, 5. This will also point to another array object. Okay, 0, 1, 2, 3, 4. Similarly, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. When this statement will be executed, your JVM will create this kind of memory structure in your JVM will create this kind of structure in your memory, right? This is how your multi-dimensional arrays work. Okay, and why this is multi-dimensional? Because you have two-dimensional specified, two dimensions specified while creating the object. Okay, first dimension has three fields, and each of these fields is pointing to another array object that has five elements, five fields. Okay, now if you want to access this position, okay, if you want to access this position, this element, right, then how you will do it? X, first you have to travel to this element. Okay, so to travel this element, you have to make a path. Okay, so first you will write X, it means go to at least this memory location first. Then on the first array, right, in the first array, go to the second field, right, or actually this is third field, but go to the field with index number 2. So I will say here 2, right? Now after that, go to the second position, go to the uh, second position or the third position or the field that is that is referred by the second index, right? Go to that position which is go to the third position in the object that is pointed by your second element or second field. Okay, so you will say here 2 equal to 30, so it will store here 30, right? Say suppose this one, you want to store some value here, you want to access this field, access this element here. So what you have to write, x on the first array, right? Go to the zeroth position which is pointed by x, go to the memory location which is pointed by x. So by writing this, you are by writing this statement, you are instructing your JVM to go to the memory location which is pointed by x. Then go to the zeroth element, zeroth field. So zeroth field. Now go to the memory location which is pointed by zeroth element, and then access the second third element, okay, in the memory location which is pointed by the zeroth element, right? So which is this one, equal to 50. So here you will get 50, right? Now if you say something like this, x 1 2 equal to, or say suppose I will say 4 equal to 50. When your JVM will execute this statement, right, how it will process, go to the memory location which is pointed by x. So this is the memory location which is pointed by x. Now go to the first position, okay, so this is my first position. Next go to the fourth position, right? So your first position is pointing to an array object that has five fields. I want you to go to the fourth position. So this is your fourth position, and I want to store 50 on it. So it will store 50 here. Okay. In map editor also, your when you have looping structures, looping elements, or looping fields, or looping records, looping groups, okay, or repeating groups, I can say repeating groups, repeating fields, repeating records, then your map editor or your translator actually creates this kind of structure, okay. And you, if you want to access a specific occurrence of a field, then this is how you have to index them. This is how you have to use the indexes, okay. Let me take one more example, even complicated, more complicated, right? And after that we will go to the 2 4 6. Now this time I have three-dimensional array, okay. This time I have three-dimensional array, okay. When your JVM execute this statement, what it will do, it will create a reference x. This reference will point to a array object, and this array object will have two elements, okay. and it will index them as 0 and 1. Okay, all these elements will point to array objects, and each array object will contain 4 elements, 4 fields. Okay, that means something like this. One, two, three, four. Okay, 0, 1, 2, 3. 0, 1, 2, 3. Okay, this is how your memory will be allocated for this up to when your 2 indexes will be processed. Okay, next 6. Each element, each field of second dimension will hold an array object, integer array object, that has 6 fields or 6 elements. Okay, each position of this second dimension will point to an array or integer array that will have capacity to hold 6 integer elements. Okay, so it will be something like this. 0, 1, 2, 3, 4, 1 more, 5. Okay, this one will also do the same thing. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. This one will also contain point to the similar array object. 0, 1, 2, 3, 4. Right? Same thing with this object also as well. 0, 1, 2, 3, 4. Okay, so you can see here how your 3-dimensional array will be created in the memory. Zero, 1, 2, 3, 4, 5. Okay, so when this statement is executed by your JVM, this memory structure will be created in the heap. Okay, now but that is not the point. Our point is how you will access this 3-dimensional array. Okay, how you will use indexes to access 3-dimensional array. Okay, now say suppose I write x 0, 3, 2 equal to 10. When your JVM will execute this statement, where it will place this 10. Okay, so you are saying By writing this statement, go to the memory location which is pointed by x. So this is the memory location which is pointed by x. Go to the 0th position. I am at the 0th position, right? Go to the array object which is pointed by the 0th position. Okay, so I will get here. Go to the 3rd position. Okay, 0, 1, 2, 3. This is my 3rd position, right? This is your 3rd position. Now again, take the reference and go to the memory location which is pointed by the 3rd field or 3rd element. Okay, so I will get here, right? Then you are saying go to the 2nd position, which is my 2nd position. This is 2nd position. Store 10, and I will store 10 in that. Okay, this is how it works. This is how we use the indexing. Another example: x 1 3, I have used 3, let's say 2 and 1 equal to 100. So suppose I want to execute this statement. So how JVM will execute? It will take the reference x. X is because pointing to this memory location, it will go here. Then go to the 1st position. This is my 1st position. Go to the object which is pointed by x field. So which is the object that is pointed by x? This field. This is the object, right? Go to the 2nd position, 0, 1, 2, right? This is my 2nd position. Go to the array object which is pointed by the 2nd position. Okay, so I will go here. On position number 1, store 100. This is a position number 1. I store 100, right? I want you to tell me the what is the position number of this element. I want to assign a value here. Okay, I want to assign a value here. I want to access this field. What will be the index, or what will be the location of this field, and or how I will identify this field. I want to store a specific number, say suppose 20, on this field. How I will access this? Okay, so first you have to write x, obviously, right? You have to write x because x is the reference that is holding the first array object. Okay, then so this guy links to this object, and then this object links to this object. So it is on the 0th position. Go to the 0. I don't need to go here. I don't want to access array object that is pointed by 1, or that is pointed by 0, or that is pointed by 3. I am interested in the object, array object, that is pointed by the 2nd field, right? So I will use the 2nd in the next dimension. Okay, then this guy points to this array object, and I want to store some value on the 2nd field, right? So I will say 2nd equal to 20. If I write this statement, or if I write this actually, right, this is the actual memory location of this field. Okay, okay, so this is how it works. Okay, now next I want you to tell me the coordinates or indexes of this field, this guy. Okay, So you can backtrack. This is linked, this object is associated with this field, which is 3, right? And this entire object is associated with this field. So it will be x 1, 1 is pointing to this, but it has every element, every field of this array object is pointing to another object. But I am interested in third one, right? I want to travel or I want to get to the object which is pointed by the third field in the array, right? This one. So 3. Okay. Then I want to store some value on the position number 2, which is on the array object in the position number 2, which is pointed by your field 3. So 2 equal to 500. 500, right? So this position is identified by, if I start from the back, 2 3 1, 2 3 1. Okay. Similarly, what about this? X 0, right? This object is reference or address of this object is in the field 0 of this array, right? So it will be 0 again, right? And then 2. Like this. Okay. So this is how your arrays are arranged or memory is created in the memory. Okay. And this is the way we use the indexes. Okay. And this is how we use indexes to access individual element or to identify a specific field in the tree of an array. Okay, a specific field in the tree of an array, right? It's very important for you to understand. If you understand this, you can access any field, any element in the map editor, right? Because your map editor also create this kind of structure that I'm going to explain you next. Okay, now let's see how map editor parse your input data. Okay, so far uh, we have used only XML, so I will explain this concept also with the help of XML, right? But this concept that I'm going to explain you, it remains same, right, for all other file types as well. The only thing that will change is, instead of element, right, in other file types we will have either record which repeats, right, or the group, right? Except that everything remains same, that I'm going to explain you now with the help of XML. Okay, so we are going to see how map editor parses your input XML, right? If you understand that, you will know how to index field to access a value in a specific field, or how to access field to assign some value. Okay, so let's say, suppose, okay, we have an XML, we have a XML, we have XML called A. Okay, inside A we have repeating B, okay, and B will repeat, okay, and then we have C. C cannot repeat. Inside C we have D, right? D1, D, D, D2. This is the value, okay. Then my C will close, and then my B will close. Similarly, because B is repeating, right, I will have another V, B, right? Then we have C, C is ending, and then we have D, D2, and this is my D3, and this is my D4. Okay. Now, say suppose this is your input XML, and you have a map created for this to consume this input XML and then translate into some other XML or some other positional file. But the point is, when your translator gets this input file, how it will process it, or how it will um, create the input structure, or how it will arrange the memory to pass this input XML, right? So I'm going to show you that. Okay. So in this case, your map editor will first create a object, right, which will have ability to point other objects, and this will be your A. This object will be for A element. Okay, this is how it will work in the memory. Okay. Oh, come on. What's wrong? Okay. Yeah, it's working. So this is for A. Then we have two B elements. Okay. So it will create an array object that will have two elements, and in map editor we index does not start with 0. Okay, index starts with 1. Okay, index starts with 1. So 1, 2, and this is for B, this guy. Okay, B. Okay, so we have two. Why I created two fields here on this object, B object? Because we have two B's, right? If we have, say suppose, one more B, then we will have one more field here in the B type. Okay, inside this B we will have C. Each element, each field of B object will contain one C object or C element. So here is my C. Okay, and this will also have C. Okay, and the index number will be 1 and 1 for this. For both it will be 1, 1. It has 1 and 2. So this is C. Each element of C will contain D object. Okay,